question 64 regards is a follow-up of example 7.14. So example 7.14 is very important. It's also a very interesting example, so make sure you see that before you work on this problem. What it's saying is that if you have a trajectory of this rocket, is that at mid-air, this rocket explodes into two different pieces. So these two pieces will follow different trajectories, but because there's no external force on this rocket, because this explosion is completely from internal force, its center of mass will still follow the same trajectory as a normal parabola. So that is to say, if you consider these pieces separately and you find their center of mass when they fall, the center of mass will follow a normal trajectory without the explosion. So this is just some really conceptual facts that you need to understand. And now, in that question, what they had is they have these two parts. This is part 2 and this is part 1. They had these two parts of equal mass. So what they are saying is, if this is distance d and this is distance d, after the explosion, if part 1 lands here, then part 2 will land a distance 2d over here, so that their center of mass is d from this symmetric point. So this question, we changed the ratio of their masses. In this question, what we have, it's without the explosion, this rocket is still expected to follow a trajectory like this. This is d, and this is d. So the coordinate is 2d. So it has this explosion here. And again, part 1 is falling here, and part 2 falls off. So since we know the center of mass is a distance of d from this one piece, then this distance is really related to this distance by the ratio of mass. So we have x center of mass equals x1 m1 plus x2 m2 over m1 plus m2. And from this, we know that x2 equals x center of mass times m1 plus m2 minus x1 m1 over m2. Okay, so this is x2. So the first case, A, is when we have m1 equals 1/3 of m2. So in this case, we have x2 equals the center of mass is a distance of 2d from the origin times, adding them up, it's 4, minus x1 is d times m1 is 1/3. So for m2. So that gives us 7/3 of d. And we can do the same for case 2 when m1 is 3 times m2. And again, we plug that in. And now we have times 4 m2 minus d times 3 m2 over m2 is 5d. So that is the distance of these two to the origin. Or we can also just try to visualize it, because if this mass is 1/3 of this, then we can imagine that m2, it would fly much further. So this ratio, this is d, this should be 3d. Then this is a total of 5d. as opposed to if this piece is much heavier, if it's like 3 times the mass of piece 1, then its distance would be 1/3 d from center mass. Then it's 2d plus 1/3 of d, which is 7/3. So from this geometry, we can see that the answer agrees with our algebraic answer.